Hello dear students of plus 2 medical and non-medical respected teachers. Today I am going to discuss a very important topic, PN junction as a rectifier. So first of all, what is rectifier? Rectifier is a device which converts AC, that is alternating current, to direct current. So device which converts AC to DC is known as a rectifier. What is its principle? Rectifier works on the principle that PN junction conducts only when it is forward bias because of low resistance, and it doesn't conduct when it is reverse biased because of infinite resistance to the flow of current. So this is the basic principle of rectifier. Rectifier are basically two types. One is half wave rectifier, another is full wave rectifier. So first of all, what is half wave rectifier? Principle is same. It states that when PN junction diode conducts only when it is forward biased, it doesn't conduct when it is reverse biased. So first of all, we have to make a diagram of half wave rectifier. So it consists of primary, secondary, that is a transformer connected to AC source, that is input is AC. Then there is a PN junction diode, and across the output there is load resistance RL. So this is the make the connections as shown in figure, circuit diagram as shown in figure. Now it's working. When AC is applied across the primary of transformer, then due to mutual induction, induced EMF is produced in the secondary of the transformer, which is the principle of transformer. So first of all, suppose when positive half cycle falls and A is positive. When and A is positive, PN junction diode becomes forward bias. It means it conducts. As a result, current flows through a circuit in the direction of arrows as shown in figure. And we get output across the load RL. When negative half cycle falls, again due to mutual induction, induced EMF is produced in the secondary of transformer and A becomes negative. PN junction diode becomes reverse biased, so it doesn't conduct. So if it doesn't conduct, so there is no output across the load. So in case of half wave rectifier, if this is the input voltage AC, then output will be like this, because when during positive half cycle diode conducts, during negative half cycle there is no output. Again positive half cycle it conducts, no doesn't conduct, conducts, doesn't conduct. So no doubt this output is unidirectional but pulsating. It appears in the form of pulses, not constant but intermittent. रुक के होती है, गैप है, but it is DC. So we have converted AC to DC, but we need constant DC. So to get constant DC, we make use of full wave rectifier. In case of full wave rectifier, again output input AC is given to the primary of the transformer, then due to mutual induction induced EMF produced in the secondary of the transformer. In this case we use two diodes and load resistance RL as shown in the circuit diagram. First of all, center C is asked, so that when A is positive, B will be negative, and vice versa. First of all, when positive half cycle falls and A becomes positive, say, then diode D1 becomes forward bias. So it means diode D1 conducts, but D2 becomes reverse bias, D2 doesn't conduct. So we get output, current flows in the circuit in the direction of these arrows in the clockwise direction, and we get output across the load, and this is the direction of current across the load. Now when and A becomes positive, negative during negative half cycle, when negative half cycle falls and A becomes negative, so B will be positive because center C is asked. Now D1 doesn't conduct because it is reverse biased, but D2 conducts because it is forward biased. So we get current in the direction of these arrows, that is in the anti-clockwise direction in the lower circuit, and this is the direction of current through the load. So we see that through the load, whether D1 conducts or D2 conducts, both the cases, when positive half cycle falls or negative half cycle falls, current is from right to left. It means current is unidirectional but pulsating, and it is DC. So the input is like this, AC, then output will be, when positive half cycle fall, D1 conducts, when negative half cycle fall, D2 conducts, D1 conducts, D2 conducts, D1 conducts. So it is not intermittent. It is unidirectional but pulsating, but it is DC. We have converted AC to DC. So to get constant DC, we make use of filter circuits, L circuit, C circuit, Phi circuit, to get smooth output of the rectifier. So this is all about rectifier. Until next video, stay tuned. Good luck and all the best.